we are learning about solving systems of linear equations by graphing. So before we talk about solving a system of linear equations, let's talk about what is a system of linear equations. Well, it is when we have two or more equations. Okay, simple as that. That makes a system. For our purposes, we're only going to be focusing on when we have two equations. But just so you know, you can have more than one. All right. Then, what is the solution to a system of equations? It is the ordered pair or pairs that satisfy the system, that satisfy both equations of the system. I'll probably make that a little smaller font, but it's the ordered pairs that satisfy both the equations. So that is ordered pairs xy that satisfy these equations. Now we have a couple different scenarios. We can have when the lines intersect, and if that's the case, then our solution is right where those 2 points cross. Like you see there. So that's a one solution scenario. So this is when we have one solution. If we have parallel lines where they will parallel lines, so they have the exact same angle, the same slope, then they're never going to cross, no matter how far you draw those lines. In that case, we would have no solution. And then our last situation is when we have identical lines. Now it looks like we only have one line here, but really there are two lines, just drawn exactly on top of each other. If that's the situation, then this is when we have infinitely many solutions. Okay. All right, so let's talk about graphing these ourselves. So ways to graph. So first we have slope-intercept form. Slope-intercept form is y equals mx plus, right? Where you would start, you begin at the b value, and you use m as your right of a run. So you begin with b, remember? That's, you either go up or down with that value, and then you use the m as a rise over run. Alright, so you rise a certain amount, run a certain amount. Make sure you have positive slope going, angling from left to right, going up, like so. That's positive slope. Negative slope goes down from left to right. Okay. Alright, so standard form. Standard form is ax plus by equals c. If you get something that looks like that, convert it into slope-intercept form. So convert to, I'm going to just do SI for slope-intercept form. So the form that we just saw right up above. Okay. If you have horizontal lines, well, first off, what kind of equation is a horizontal line? That's y equals and then just some number. All right, don't know the number right at the moment, but you know, it could be any number. If that's the case, you go either up or down, depending if it's positive or negative. Up for positive, down for negative, and draw a horizontal line right there. For a vertical line, it's very similar, but it's x equals a number. Then you would go left or right, depending if it's positive or negative, and draw a vertical line. And if other things that must be converted into slope-intercept form, that's basically anything else. Anything else you see that's not what we've already talked about, convert into slope-intercept form. All right, let's take a look at some of these. So our first situation, we have both of them are in slope-intercept form, and we've got a slope of 1. I wanted to write here. We have a slope of 1 over 1. All right, so we're going to start at -8, right here, at a point, and then rise 1, run 1. Positive slope is angled this way. From left to right, it's going up. So up 1, right 1. Up 1, right 1. Up 1, right 1, and keep going with that pattern. And same thing going down. All right, and then we will graph a line that goes through those points. A ruler could be handy here, if you have one. I have some in the box in the back of the room that you can use for help. Same kind of thing with this other line, except it's going to be -2 over 1 for the slope. Start up 1. Now remember, negative slope is angled this way. And I'm not going to bother going up and left because I know that I want to intersect somewhere with this line. So I'm going to go down 2, right 1. Down 2, right 1. Down 2, right 1. All right, that's going to be our important spot. I'm going to keep going so I have a nice line to draw. And let's make our nice perfectly straight line. Get arrows on both sides, and here we go. And there we go. So my point is where those crossed at. And it looks like the coordinates of that are 3 and -1, 2, 3, 4. -4. -4. So that is the solution. And that's how you would write it in ordered pair form. And if you want, add a little, circle it. Hey, that's what it is. Okay, let's try another one. So with this one, my slope is 1/2 x, or 1/2, and I'm going to start up 9. So up 9, way up there. And it's a positive 1/2 slope, so I'm going to be going up from left to right. So up 1, right 2. Can't go any further that way, so I'm going to go down 1, left 2. Keep that pattern going. And make a line. Let's make it a blue line. Like so. Alright, let's do the same thing, but with the other guy. So that's a -1 slope, so -1. It might be more useful to think of it as -1 over 1 for rise over run. Starting at 6, 9, 8, 7, 6 right there. -1 is going to be going angled like this. So if I go up 1, then I would go left 1. Up 1, left 1. Following the rise over run. And trying a line. Oop. Gonna have to move that one a little bit. There we go. So those cross right here. And the coordinates of that, we've got, what is that, -2, up 8. So that's where those lines cross. That's the solution to the system. All right, so for these ones, we have to do a little converting. So let's rewrite that as negative 3x plus y equals 8. And we want to eliminate the negative 3x. So I'm going to add 3x to both sides. Now, since, so those 3x's are going to cancel, I'm just going to have y on the left side, and on the right side I'm going to have 3x and 8. Let's put that 3x in front of the 8, and since it's a positive 8, it'll be plus 8. Okay, so that's going to be my new equation after adding those 3x's to both sides. Canceling on the left. Oh, that's my slash for the cancel. And then think of this slope as this positive 3 over 1. So we're going to start at 8. So that's 10, 9, 8 right there. Positive 3 over 1 slope. So if I can't go up and over 3, or up 3 over 1, but I can go down 3, left 1. And keep going with that until I can't go anymore. Like so. And let's connect these guys. Like so. Alright, let's do the same thing with the other one. So at first I have negative x plus y equals negative 2. So we want to add x to both sides. That's actually right, it added a 1x. Now I'll only have y left on the left side equals 1x minus 2 because of the negative 2. So I was canceling those. And to make the slope a little, it's rise over run, right now I have a rise of 1, and the run will also be 1. Let's graph this in purple, how about, so we can see it differently from the other line. Starting down 2, and it's got positive slope, so if I go down 1, I would go left 1. And there's our special spot where they're crossing. Let's give it a purple color. There we go. So the solution is where those 2 points are crossing, right there. And that is, okay, let's make it a green color. We had negative 1, 2, 3, 4, 5. And the y value is negative 3, 4, 5, 6, 7. Negative 7. So that's my ordered pair. Okay, number 4. So first, let's write out that top equation, x plus 2y equals 4. We want to get that y by itself, so first let's subtract x over, and I'm going to subtract it as a 1x, subtract 1x from both sides. Then I'm going to have 2y on the left side, and put that negative 1x before the 4. Since it's a positive 4, it's going to be plus 4. Now I want to get rid of that 2, so I'm going to divide by 2 on both sides. So I'm just going to draw that in. So divide by 2. And when I divide by 2, I'm going to divide everything by 2. So divide this negative 1 by 2 and the 4 by 2. The 2's cancel, and we will get y equals, that's going to be a negative 1/2 slope. Actually, I'm going to put that 2 underneath later. And then 4 divided by 2 is 2. So what I meant by that is I'm going to write it as a negative. So it's a vertical fraction. We can see the rise over run a little easier. But yeah, keep that as a negative 1/2 for the slope. Okay, so I'm starting up 2 and negative 1/2 slope. So if I go down 1, I would have to go right 2. And same thing going to the left. put our line down. All right, now you might notice the other equation, the second one, is just what we exactly had. All right, so maybe I'll graph this one in orange, let's say, and I would have to graph it exactly on top of that last one. Now I'll try to angle it so you can see both colors a little bit still. So you can kind of see that there's two lines there, but they're the exact same line. That means they're crossing an infinite number of times. So in this case, our solutions are infinitely many solutions. Okay. So whenever you have the same line, that means you're going to have infinitely many solutions. All right. Number 5. So x plus 3 equals negative 15. That one's going to have to be converted into slope-intercept form. First step is to subtract 1x from both sides. And we'll have 3y equals negative 1x minus 15. Now we're going to divide both sides by 3. Move that up a little bit. Let's keep going with that orange color. So dividing them by 3. Divide each part by 3 here. Cancels in the front. And I'm left with y equals negative 1/3 x minus 15 divided by 3 is 5. So there's my equation. I'm going to start at negative 5. And I'm going to have a negative 1/3 slope. So go down 1, right 3. Same thing going the other direction. And graph our line. Like so. Okay. The other one is just y equals negative 7. So remember how we talked about that? Horizontal line, just go up or down that amount. In this case, we're going to go down 7. So that's right here. And draw a horizontal line through it. So like so. Now where do they cross? Let's check that out. That is, let's see, writing that answer down. Green color. 1, 2, 3, 4, 5, 6 for my x coordinate, and then negative 7, of course, for my y coordinate. Well, I say of course because that is what the second equation is. It's y equals negative 7, so y is always negative 7 from that line. Okay, and number 6. So first off, the first one has a slope of 1, or 1 over 1 for our purposes. So start up 5. And positive 1 over 1. And there's lots of spots to make points, like so. Alright, now the second one we're going to have to do some conversions with. So it's x minus y equals 2. First, we want to get rid of that x. I'm going to subtract it as a 1x from both sides. Then I'll still have a negative y left on that left side. So negative 1y, I'm going to write it as, equals negative 1x. And it's a positive 2, so plus 2. So what's going to happen here is these x's cancel. That's why we only have a negative 1. I put the 1 in front of that y. We still want to get rid of that negative 1 by dividing by negative 1. And in all three spots here. Cancel in the front, and we get y equals, so negative 1 divided by negative 1 is just 1. Positive 1. And positive 2 divided by negative 1 is a negative 2, so I'll write it as a minus 2. And I'm going to write that slope as 1 over 1. So starting down 2, and we have a positive 1 over 1 slope. That's the same slope as the purple graph. So they have equal slopes, and you may notice that they are not crossing. So in that case, that means that this is a no solution. No solution. That n is getting in the way. All right. So try out the 5-1 homework to practice this.